name is Jonathan Brendefur from DMT Institute, and I'm going to go through how we model adding fractions. So hopefully you just listened to how we talk about fractions, what the numerator and denominator is. So we talk about the numerator as the count, and the denominator as the unit size, or how many equivalent units it gets to 1. So you can watch that video. There's also two words that we're going to use quite a bit when we're talking about fractions. Partition, these are both structural words, so structure is kind of words that we could be using from kindergarten all the way up through calculus. So partition in mathematics means to split evenly, and iterate means to copy with no gaps and overlaps. So in this case, we're going to use, there's two models that we tend to use when we're describing fractions. That's either the bar model or the number line tend to be the two best because it shows a continuation and it also shows proportion. So we are going to first start with 5/4 plus 3/4. So initially we want to be able to model it and talk about what each of these digits mean in the model before we really get into adding much more difficult fractions, which then we'll move to the algorithm and things like that. But initially we're just going to model it and talk about the language to describe this. So as we talked about the definitions, so we start with the denominator, and the 4 means it's going to take us 4 equal units to get to 1. So we can do that with a number line or a bar model. I'm going to use a bar model and represent 0 and 1, partition it into 4 equal sections, each of those to represent those 4s. So here I have 0/4, 1/4, 2/4, 3/4, 4/4, and again, the numerator talks about the count. How many do we have? We have 5 of these 1/4 units. So here I have 1, 2, 3, 4, and I have one more, which would be 5/4. So there I can describe I have 5/4 units, 5/4, or it also shows I have that 1 unit and 1/4, which is equivalent to 1 1/4. Here, initially, it's easier to describe and just talk about that I have 5 1/4 units or 5/4. Now I'm going to add on 3/4 or 3 more 1/4 units. So again, I'm counting in the same unit, so I can continue counting another 4, 6/4, 7/4, 8/4. So I've added on 3 more 4s. That gives me a total of 8/4. So 5 plus or 3/4 is going to equal 8/4, which is, we notice here that 4/4 is equal to 1, equivalent to 1, and another 4/4 would be another unit of 1, which would be a whole number of 2. So 8/4 is also equivalent to 2. So the bar model, again, helps us really model and talk about what each of these digits means. So we're counting in units of force in both places. I have a count of 5 of them. I have a count of 3 of them. So if I compose all of them, I'll have 8 1/4 units, which is also equivalent to 2 units of 1. Okay, let's do one other problem where we're not in the same unit. Okay. So what if we had 5/8 plus 1/2? Now here, when we put units together, they have to be the same size units. This is common when we put ones together, we put tens together. Later, we would put tenths together. In algebra, we put like terms together. In fractions, we call them like denominators or like size units. These are not the same size units. So getting kids to think about 8. Okay, so we go back to the first denominator. I'm going to model again with a bar model, or you could use a number line. Here's 0, here's where 1 is. 8 tells us we're going to partition the 1 into 8. And this is a good task of just having kids practice being able to partition correctly and proportionally. 1, 2, 3, 4, 5, 6, 7, 8. 8 smaller units to get to 1. So each of these represents an 1/8. I have 5 of them, 2/8, 3/8, 4/8, 5/8. I'm just going to shade that. 1, 2, 3, 4, 5. Now I'm going to finish off the ace. There's our 5/8, 6/8, 7/8. 8/8. So when we have 8/8, we have a unit of 1. That means if we had 16 of them, we'd have a unit of 2, equivalent to. Now what we have here is we have 1/2. They're not in the same unit, so we have to create that equivalent fraction. So down here, I'm going to add on a half, but I need to do it in eighths. So if I don't know what that is, I'm going to initially do the same unit of 1. The half tells me I have 2. We have 1/2 and 2 halves to get there. I have a count of 1 of those halves, but now I need to create this into 8. So I'm going to partition each of these in half. That gives me 4 units to 1, so that'd be 4ths. I'm going to do it again, half, 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 and that gives me 8 units. So 1, 2, 3, 4. So that's an equivalent of 4/8, because each of these little guys here are 1/8 units. So 1/2 is going to be 4/8. So I need to be able to add on 1, 2, 3/4, 1 more 4th, and that is, eighths, 1, 2, 3, 4/8, which gives me 9/8. So that 1/2 is equivalent to 4/8. Altogether, that is 9/8, or I have a whole unit of 1 and 1 more 1/8. So again, the modeling helps us really understand what each of these digits means. I'm counting in units of eighths. I have 5 of them. I'm counting in units of halves. I have 1 of them. To combine them or to compose them together, we need to have common denominators or common size units. So we have to convert one of them into the other to be able to add them together. We could have written that as 5/8 plus 4/8 is equal to the 9, counting 9, but still in the size unit of eighths, which is equal to 1 and 1/8. So that gives a quick introduction of how to talk about and model fractions, which will then help us think conceptually about adding much more difficult fractions when we start using just more symbolic models and algorithms later.